Hello guys, welcome to another video from Computation channel. In this video, we're gonna solve the symmetries problem from first chapter in Sipser textbook, and actually in this problem, we're gonna train and that how to build a specific NFA for a language, and after that, turn it to equivalence DFA for this question. And yes, that's it. Let's solve it together, guys. Okay guys, this is the question that we have. Question number 17. Part A, give an NFA recognizing the language, actually 0, 1, the union of 0, 1, and 0, 0, 1, and 0, 1, 0, and after that we use from clean start to actually somehow generate all of the things that we can generate with this substring here. So let's go to notebook here. I write the language that we want to construct the NFA for it. So for first step, let's break down this language to actually a smaller part and try to make a equivalent NFA for any of this part, and after that somehow we can attach and use all of this NFA that we're gonna construct here and reach the final NFA for our language. So first for this part actually here 0, 1. So our language is 0, 1. We can use from actually this tree here that somehow we learned it in the previous episode that I will give you the link here, that we can construct the equivalency NFA for this language, and it will become like this actually. If I want to construct it for you, it will become like this. We have here Q 0, and after that we will see 0 and reach Q1, and after that we need an actually epsilon, and we will reach Q2, and after that we will see 1 here and we will reach Q3, and we know that Q3 is our accepted state here. So this is the equivalence NFA for first part. For next part, we must construct the NFA for 0, 0, 1. Actually, so for 0, 0, 1, again, we must construct our NFA like this. We have Q0, after that we will see 0 and we will reach Q1, and after that we need another epsilon, and after that we will reach Q2, and we will see another 0 here, and we will reach Q3 here, and after that another epsilon, and finally we will reach actually Q4 here, and after that we will see the final one and we will reach Q5, which is our accepted state here. So it will become like this. That was for 0, 0, 1, and for final part we have 0, 1, 0. So it will become like this. 0, 1, 0. First we have Q0 here, and after that we need a 0, and we will reach Q1. We will see another epsilon here, and we will reach Q2, and after that we need a 1 here, and we will reach Q3, and we will see another epsilon, and we will reach Q4 here, and finally we will see the final 0 and we will reach Q5, and this is our final accepted state here. So we construct the equivalence NFA for all of these parts here. For next part we need the union for all of these languages here. So first our language will become like this. We have 0, 1, the union of 0, 1 and 0, 0, 1 and 0, 1, 0, and it will become actually like this. So we know that if we want to make the union of some languages, first we need to add another actually a start state to our language, and from that state we will add epsilon transition to all of the previous start state that we have for all of these parts here. So somehow our language will become like this here. We have Q0, which is our start state. we have Q0, and after that we will add epsilon transitions like this to our previous actually starter state that we have. The first part is 0, 1, so it will become like this. Actually, Q1, we will see 0, and we will reach Q2, and after that another epsilon and Q3, and finally we will see 1, and we will reach Q4, which is one of our accepted states. After that we have 0, 0, 1, which will become like this. We have Q5 here, and we will see 0, and we will reach Q6, and we have, after that we have another epsilon, and we will reach Q7, and after that we will see another 0, and we will reach Q8, and another epsilon, and we will reach Q9, and finally we will see another 1, and we will reach Q10, which is one of our accepted state that we have. So somehow it will become like this. And so for final part we have 0, 1, 0. So again we have, actually let's continue our counting. We have Q11, we will see 0, and we will reach Q12 like this, and after that we will see another epsilon, and we will reach Q13, and we will see 1 actually in this part, and we will reach Q14, and we will see another epsilon, and we will reach Q15, and finally we will see another 0, and we will reach Q16. So it somehow it will become like this, and Q16 is one of our accepted state. So somehow this is the NFA that we construct for this language, the union of 0, 1 and 0, 0, 1 and 0, 1, 0. But if you notice here, our final language have a specific clean star here. So somehow we must add this to our language. So our final language will become like this. The union of actually 0, 1 and 0, 0, 1 and 0, 1, 0, and finally we will use from clean star, and it will become like this. So if we want to construct the final NFA for this language, we have actually from last part we have this NFA that will give the union of 0, 1 and 0, 0, 1 and 0, 1, 0. And here if we want to add clean star, we must add actually an extra starter state which will become one of our accepted state, and we must add some epsilon transition from the final accepted state that we have here, I mean Q4, Q10 and Q16, to our actually previous starter state that we have here, which is Q0. So if I want to show you, we must add an extra accepted state here, which is actually we will call it Q0 like this, like before actually, which is one of our accepted state, and yes, it will become like this. And after that we must add an epsilon transition to our last starter state, which was Q0 in the last part. So here it will become Q1, and here it is not one of our accepted state, which I explained the reason behind it, and I will give you the link to that video here. After that, all we have to do is that we must add the parts that we construct before. So here we must add 3 epsilon transition, so it will become like this. Actually we have 3 epsilon transition, and it will become like this. After that we will call it Q2, and we will see another 0, and we will reach Q3, and after that we will see another epsilon transition, and we will reach Q4, and if we see another one here, we will reach Q5, which is one of our accepted state that we have here. So it will become like this. After that we must add 0, 0, 1 part. So here we have Q6 here actually, and after that we will see 1, 0, so we will reach Q7 like this, and after that we will see another epsilon, and we will reach Q8, and another 0 and Q9 here, and we will see another epsilon Q10, and finally we will see another one, and we will reach Q11, which is one of our accept states. So yes, it will become like this. And for the next part, actually, we have a 0, 1, 0 part. So again, we have Q12 here. Yes, and we will see another 0, Q13, another epsilon, and we will reach Q14, another one, and we will reach Q15 actually, another epsilon, and we will reach Q16, like this, and final 0 that we will reach Q17, which is one of our accept state. So it will become like this, but we don't have to forget this part, that we must add some extra epsilon transition from our final states to Q1. So somehow it will become like this. We have one epsilon transition here, and we have one for this part, like this, and we have another epsilon transition here, like this, for this part. And yes, this is the final NFA that we can construct for this specific language, which is linear star of union of 0, 1 and 0, 0, 1 and 0, 1, 0. So here we solve the part A of this question. After that, we have part B. Convert this NFA to an equivalent DFA. Give only the portion of the DFA that is reachable from the start state. So we know that if we have k states in our language that we construct, or better I say the NFA that we construct, if we want to convert it to equivalence DFA, we will reach 2 power of k states in our DFA actually. So it will become like this. But we must notice that if we use from actually the trick that the Sipser textbook give us, some of the states that we can reach them, actually we can construct them, are not reachable from our start state, and we can't start from our start state, first start state, and reach the new state that we construct for our DFA. So actually here we only need the parts that we can reach them from our start state. So let's start to build the equivalence DFA. We know that first we must actually somehow show our start state, which is here. We call it actually S here. Yes, it is good. We call it S. So we know that if we want to convert the NFA to equivalence DFA, we must notice to epsilon transition. So here our start state is Q0, and we can use from all of our epsilon transition here. So here, if we use from epsilon transition, we can reach Q1, Q2, Q6, and Q2L. And actually we can add Q0 here because we know that the state that we start from this point is one of our actually a state that we can reach it with epsilon transition, and we must add it to them. So here we have Q0, and Q0 is one of our start states. So here S will become the start state, or better I said, one of the start state that we have in our final DFA. So yes, it will become like this. After that, so we know that in our equivalence DFA we must have the actually transition arrow for any of our alphabets. So here our alphabet is 0 and 1. So in S we will start with 0. If we start with 0 here, in S we may be in Q0, Q1, Q2, Q6, and Q12. And if we use from 0 here, we can reach Q3, Q7, Q13, and after that we can use from epsilon transition again, and we will reach Q4, Q8, and Q14. Actually, this, if I want to show you, we can reach these states here. Yes, this states here, and in this state we don't have any active state. So if we call this new state actually a state A, we know that it is not an active state. So yes, 0, and we have A here. After that, if we want to check for 1, if you take a look at our language here, we know that any of our language won't start with actually 1. We have 0, 1, we have 0, 0, 1, and we have 0, 1, 0. And in any of them, we don't start with 1. So if we are in our start state, and if we want to actually start with 1, we never will reach one of our active state. So actually, we must add another state that we may call it data state, that we know that we will never reach one of our active state from this state. So here we have actually 1. Yes, we have like this one, and we will call it data state like this. And we know that when we reach this state, we can't reach the one of our final state. So we can add this transition here like this. We have 0 and 1. Yes, it will become like this. After that, from state A, we are in Q3, Q4, Q7, Q8, Q13, and Q14. After that, if we see another 0, we know that from Q3 and Q4 we need a 1 to reach the actually next state here. So we can't use from Q3 and Q4, and like these states we can't use from Q13 and Q14, because again we need actually 1 to reach our next state. So our only option will become Q7 and Q8, and after that, this state, if we see another 0, we will reach Q9 and Q10 actually, and it will become like this. If I want to show you, we have these states here. Yes, we are now in Q9 and Q10, which we don't have any active state between them, so we must add another state again for our equivalence DFA. So it will become like this here. Actually, if I want to show you, after A, we must add actually C here, or better I say B. We add B state here that we can reach it actually with 0. Yes, it will become like this. And after that, if we want to check 1 for state A, we know that state A was Q3, Q4, Q7, Q8, Q13, and Q14. And we can use from Q3, Q4, and Q13 and Q14, which we will reach actually Q5, which is one of our active state here. We will reach Q15, and after that we can use from epsilon transition and reach Q16. Also from Q5 we can use from epsilon transition again and reach Q1, Q2, Q6, and Q12. And because we have Q5 in and it is one of our active states here, so our newest state will become one of our active state, and actually somehow it will become like this. We have one transition here, and we will call our newest state as state C. So yes, it will become like this, and we know that it is one of our active states here. And yes, that was for state A, and after that we will continue from state C. We know that actually if we see 0 and 1 in our language, after that we must see another 0 if we want to reach another active state here, because if we see 2, 1 after each other, we know that it won't actually be in any of our substring. We have 0, 1, we have 0, 0, 1, and we have 0, 1, 0. So we know that from state C, if we see another 1, we will reach data states here. So it will become like this. And for actually 0 string, actually from 0 string, we know that when we was in the actually state C, that we are in Q5, Q1, Q2, Q6, Q12, and we are in actually Q15 and Q16. And after that, if we use from another 0, we can actually reach Q3, Q4, Q7, Q8, Q13, and Q14 from Q2, Q6, and Q12. And actually, we can use from another actually 0 from Q15 and Q16, and we will reach Q17, which is one of our active state. So if we use from another 0 here, we will reach a new state, which we call it actually D here, and it is one of our active state because we have Q17 in it, and Q17 is one of our active state. So until this part, our DFA will become something like this, and after that we can continue with state D. So if we want to actually continue with state D, and if we use from 0 again, actually here we are in Q17, which is one of our active states, and from epsilon transition we can reach Q1, Q2, Q6, and Q12, which are not any actually active state. And after that we can use from 0 and reach Q3, Q4, Q7, Q8, Q13, and Q14 actually, and also they are not active states. So here we will reach a new state, which we call it actually somehow E here. Yes, like actually like this. And we use from 0 transition here. And if we want to check for 1 on our D state here, we was in Q17. So after that we can reach Q, actually, if we use from our epsilon transitions here, we will be in Q1, Q2, Q6, and Q12. And for any of these states here, we need another 0 to reach our next state. But here we have a 1. So somehow it is not correct, and we can't use from these methods here. So what should we do? Actually, here we can use a trick. We know that when we was in D state, we have another states here. Before that, actually we read 0, 1, 0. So somehow we are in Q3 and Q4. And here, if we use from another 1, we will reach Q5. And it is one of our active states. So somehow if we use from the union of all of these states that we will reach them in D state, we will find out that the new state actually is C. And yes, before this part we make the state C, so all we have to do is that we will use it again, and our DFA will become like this. So actually 2 parts left. We have a state B and somehow a state E. So let's continue with a state B here. From a state V, before that we have 2, 0. So we know that with 2, 0, actually we are in Q9 and Q10. So if we use from another 1, we will reach Q11, which is one of our active state. And after that we can use from epsilon transition and reach Q1, Q2, Q6, and Q12. So with this, actually, somehow we can back to our start state here. And yes, it is correct. There is no mistake here. We can use from our start state here. And you may ask yourself why we use from our start state again. Because actually, when we are in B, we are in one of Q9 and Q10 states. So after that, if we use from 1, we will reach Q11, and from that we can reach Q1, Q2, Q6, and Q12, which we use them in our start state. So we can use from this transition here, and yes, it is correct. And after that, if you want to check it for 1, we know that from Q9 and Q10, if we want to use from 1, if we want to use from 0, we can't reach any states here. You may ask yourself why. Because from Q9 and Q10, we have only one transition, and it is for 1. And we can't use from 0 transition here. So here we must add another transition, which we can access our data states again, and it will become like this. Yes, that was for state B, and now for state E. For state E, we use from 0, 1, 0, 0. Okay. Actually, after that, if we use from another 0, it will become 0, 1, 0, 0, and 0. You may ask yourself, we must use from what string to reach this state here? Actually, we can use from 0, 1, 0 first, like this, which is one of our substring that we have in our language. Here, we have 0, 1, 0. Yes. And after that, actually, we can use from 0, 1, or we can use from 0, 1, or 0, 0, 1, or 0, 1, 0. It will become like this. So here, if we want to use from 0, 1, we must actually reach another active states here, which is one of our difficult part that we have here. If we use from 0, 1, 0, we will reach the part D here. And after that, if we want to use from another one, we must reach another active states here. So we can use from part C again. And it will become like this, because again, we can start our substring and generate other strings here. So yes, it is correct. And if you want to check for a string 0 here, we must check the string 0, 1, 0, 0, and 0. Again, you may ask yourself which string will it become. So here we have 0, 1, 0 for the first part, and after that we have 2, 0. If you look at our substring here, we can't use from 0, 1 here, so we can use it. We can use from 0, 1, 0, but we can use from 0, 0, 1. And if we add another one, we will reach one of our active states again. So here we can use a trick and actually somehow add another 0 to this part, actually, and it will become like this. And if you take attention here, if from S, if we use with 0, 1, 0, we will reach part D, and after that, if we use from 2, 0, we will reach part B. And after that, we can use from another one and reach the start state, which is one of our active state, and this is correct. But if we use from 3, 0 after D, we will reach data state, and yes, again, that is correct. And this is the equivalence DFA for the states that we can reach them in our NFA if we start from our start state. And yes, this is the answer for question number 17 of Sipser textbook. I hope you guys enjoyed this video and learn a lot of things from this video that you can use them in your practices, in your exam, and anywhere else that may come in handy. If you like this video, like it and subscribe to my channel. And if you have any opinion, leave them in the comment part. I will read all of your opinion, which is so important for me. And yes, that's it. Have a nice day, guys. Goodbye.